a cone. No, is not a cylinder. That is a 3D shape. Thanks. What else? It was on my mind. So, yeah, pyramid. So those are the two that we're doing. 11.3. Guess what? This is probably it for the year. We might do one more chapter, like one more little thing, but this is your last lesson. Yeah. Because this is the last one. Question. Some people, I don't know why people didn't vote. Okay. Pyramids and cones. Okay. I don't like that one. Okay. Draw a pyramid. Any pyramid you want. Remember when I talked about the hippie thing? Which I didn't talk about with the other class? That was pyramid too. So, pyramid. Let's go over pyramid. Draw a pyramid. Any pyramid you want. Okay, you do a tetrahedron. What's your base shape? No, what's your base shape? No, it's good. What shape is it? A triangle. You, what's your base form? What shape is it? A square. Both of them are totally fine. If you do a hexagon, a pentagon, that's totally fine as well. So let's sketch a pyramid. Okay, I gotta say, I think this is the best pyramid I've drawn so far. I'm not joking. It really is. Except this should be slightly buffered in the back. Boom. Okay. What's my base in this problem? A square. But it could also be something else. Raylene drew a triangle as the bottom. Like so. Either one of these is totally fine. Both of these are pyramids. This is a special pyramid. This is a tetrahedron, which is one of those Platonic solids. It could be a hexagon on the bottom, which we call it a hippie. It could be a pentagon. It could be an octagon. It could be any shape it is. So volume always starts with big B times H. So Raylene, for this guy, this one wasn't yours. What is big B stand for again? Yes, it means area of base. So the area of this base would be what? Like, what's the formula? Yeah, base times height. Kind of like length times width. Base times height. So we can stick with that. Base times the height over there. So base times height, that is the area of the bottom. Now, my height for pyramids is drawn a very particular way. Just like when we were trying to find the height of a triangle. We go from the very, very top. This is my vertex up top. Vincent, you writing this down? Yep. We're going to go to about the middle. Pretend that's the middle of this square. We go all the way down. This makes a 90-degree angle. Ashley, do you mind closing the door? Thank you. This is what we call our H. I don't like having the other two H's. So let's call this length times width. And call this length times width for that one. So length times width times our height there. we're not done. If I had this equation, this would be for a regular old prism without meeting up at the top. So we have to take this formula. I'm going to scooch my volume back a little bit. We multiply this whole thing by 1/3. Volume equals 1/3 of my equation.
It's divided by 3.
Yeah, that's fine too. So all of my pyramids is going to be multiplied by 1/3 or divided by 3. Whatever way you want to do it, that's totally fine. Our numbers might just get ugly, so having a fraction isn't always the prettiest. So multiplying it by 1/3. Like so. Because we're leaving out area from the other thing, like if I drew a prism around it. Wow, this is a bad prism. Pretend that line didn't go there. There's area up in the top that we're not taking out. That 1/3 gets rid of all of that volume away. Okay, well that is pyramids. Now let's talk about cones. What type of base does a cone have, Vincent? When I do a cone, what type of base does it have? A circle. So let's all start with a circle. And just like a pyramid, we meet at one point at the top. 1 point at the top. So down below and down below. I've got to do the tetrahedron. We'll go back and do that in a second. Okay. Again, my volume for this one is volume equals 1/3 base times height. So, what is my base? Is a circle. What is the area formula for a circle? Yeah, pi r squared. So pi r squared, and we bring down the height from above. So let's make sure we can label these. How do I draw a radius? Go back to our circles and memorizing circles and everything. Drew, how do I draw a radius of a circle? Yeah, out to any point over here. So let's do right there. So my circle is my base. This is my radius. And the same thing with the height. Going up from the top, drawing it straight down to that same point. And it makes a what type of angle? 90-degree angle right there with my radius. So this is my height. And you can just, this is my formula. Keep that one. First one is just the base for a pyramid that we're taking. Okay, tetrahedron. Let's go back to this guy because I forgot about it. The base of the shape is what? A triangle. What is the area formula for a triangle? Base times height. This right here is the base. And if I draw a line from here down here, 9 degrees, that is my height of that. So volume equals 1/3. Take this equation, plug it in for big B. So now I have 1/2 base times height, and I still have my height of my entire pyramid. So I'm going to draw that one in blue. So go from your top vertex, go down to the center, and that also makes 90 degrees like so. That is this height. This is my height in blue. That's the height of the entire thing. This is the height of just the base. I would not simplify that further for now. Keep it like so. Don't multiply the fractions. Okay. Those are our formulas. If we change my base, there is other formulas that it could possibly be, but we are going to stick with the two basic ones for now. So this one and that one. We all start with this. This is the start equation for all pyramids and all cones. cones are always gonna have that one. This one depends on the base. Cool. Okay, I'm gonna go over to this problem for a second, and I'm gonna steal one from here because I didn't print these out. Let's do this one together. Okay, let's write down, edit, paste. That's my problem. Write it down and I will erase it and get some room for us to do it. And it won't even let me erase. That's so funny. It will let me erase everything from the other one, but not this one. Okay, maybe I'm just gonna scooch over. I can't scooch over. I'm running out of room. You know why? Because I think it's in a different one. Because we're in third hour, and I've been writing in second hour this whole time. Okay. Well, it's gonna stay over there. We have it in our notes. Paste the problem. Okay. Dean's in the other class, but we want to use his name, or do you want to change it to someone else in this class? Drew said change it. Ashley said good with it. Keep it? Okay, fine. Dean has a truck. Does Dean have a truck? No? Oh. Well, I didn't know that. Okay. Oh no, he talked about a dirt pile, so I made him the name in this problem. Okay, Gian has a truck that can haul 1.75 tons of dirt per load. 1 cubic meter of dirt weighs 0.8 tons. How many loads will Gian haul to move a pile of dirt that's 1.7 meters tall and 4 meters in diameter? I want you all to imagine a pile of dirt. What does it look like? A circle. What else? Just a circle? A pyramid. Okay. I wish there was a pile of dirt outside. Is it, Ashley, when you think of a pyramid, does this dirt pile have straight sides? Yeah. Okay. Does a pile of dirt have straight sides? No. We kind of just all dump it up top and it filters down. What shape do we think that is? A cone. So yeah, it's a gigantic cone. So we have the base of it like so. Up top, down below, down below. This is our dirt pile. Carson, tell me about the dirt pile. What do we know about it? Ooh. Very true. Talking just about the dirt pile, what dimensions do we know about it? Yeah. So let's draw our height. So this is 1.5 meters. And then our radius is how much, Raylene? I can't zoom in. So it says that how many loads will Gian haul to have a pile of dirt, to move a pile of dirt that's 1.5 meters tall and 4 meters in diameter. So what's our radius? 2, yeah, 2. So we have 2 meters there. Okay, Carson, how should I start? What do I need to find first? I need to haul all this dirt. What might help me know about all this dirt? Yeah, we're gonna need to know the weight. 1 cubic meter, so 1 meter cubed equals 0.8 tons. So I need to know the weight. I need to first figure out the what of this dirt pile. If I have meters cubed, that's telling us that the volume, one volume of this equals 0.8 tons. So I need to find the total volume of this. So what formula should I use?
B equals pi r squared.
Yeah, 1/3 of it, right? Pi r squared times my height. So we know that our radius is 2 meters squared and my height is 1.5 meters. Okay. What do I get when I multiply these all together? Everyone grab a calculator. Everybody. I want to make sure we all know how to put pi into the calculator. What you get? Oh, hit the little thing that looks like arrows pointing away from each other. Yeah. What did you get? .2. Cool. Let's round it to 6.3. Oh, not that. 6.3 meters. What? Cubed. Meters cubed. Okay. That's how much dirt I have in meters cubed. I don't want meters cubed. We want it in tons. How do I convert it to tons? How do I convert it to tons? 1.75. So close. We have a conversion that 1 cubic meter equals 1.8 tons. So I'm going to take this ton. Because this is how much Gideon can haul in one truckload. So we don't know that yet. But we want to convert this. We know that 1 meter equals 1.8 tons. So I can divide this by 0.8 tons. Because it'd be like 1 over. Yeah. Okay. What would this simplify to? Should be 5.04. What is my units? Tons. Because it's like 6.3 meters cubed over 1 times 1. Oh, I should be multiplying it, not dividing it. No, I should be multiplying it. 6.3 times 0.8. Yeah, sorry. Scratch that. My bad. I can't put it in the bottom. Because then I wouldn't get rid of my units. Okay. Let's back it up. Let's write it better. Okay. I need to take this conversion. I need to multiply it. So I have 1 meter cubed in the bottom. Up top, I need my tons. So this is equivalent. This is another word for like a clever choice of 1, because I said that these two are equal to each other. Raylene, the meter squared right here, they cross out. They disappear. So then I'm just left with tons. That's how we get tons. So what is 6.3 times 0.8? Not divided by. Yep, 5.04 tons. Okay, that's how many tons is all my dirt. Guillen's truck can haul 1.5 tons per trip. How many trips does he have to take to get rid of all of this dirt? Find that out on your own. You got it. You can take 1.75. He needs to get rid of. Oh wait, needs to get rid of 5.09. He can take 1.75 per trip. How many trips is it going to take? Per trip. How many trips will it take? Should I go up or should I go down? Should, because it's 0.8. 0.8. Yeah, yeah. Okay, we should have taken our tons 5.0. I just sucked in so much air. Divided it by 1.75. This should have gotten us to 2.88 trips. Now, you might say round up because, you know, it's 8. But why are we really rounding up? I want you to give me a logical, non-math explanation of why we are rounding up. Can he make a 0.9 trip? No, he has to take a full extra trip to do that. So yep, 3 trips. Cool? What was the hardest part in this problem? Like what shape? Or figuring out. The good thing about this one is it does say diameter. So it gives you a hint that it's going to be a cone with the diameter. And then, yeah, labeling it can be a little tricky. Well, guess what? I'll label the next one for you. But you all have to get up. And we are going to do it in groups. On boards. Yes. Okay, random? Okay. Random. You know, I did random with 5th, and they were very annoyed, and they said no more. Yep. Oh. I am trying to provide you a list. Okay. 3 groups. Let's see. How many times? Fine. One more. Okay, go into groups. Yeah. One more time.
Let's keep these ones. No more. Sweet.
I'm trying to divide people. Go. Okay, I'll give you a problem in a second.
Is it?
I have no clue what the groups were. I have no clue what the groups were. Okay, example. I'm going to give you a shape. Oh. This is a box. I will give you the dimensions in a second. I'm going to drill a hole in this box. The hole looks like this, going down to a point. I want you to find the remaining volume of the shape around it without the hole I just drilled. So how much volume is left in the shape? I will give you dimensions.
It's like a cheesecake.
It does look like a cheesecake. I just drilled a hole into a cheesecake.
In a regular cheesecake.
You know, I can't wait to go to like the Cheesecake Factory when I get back.
Isn't New York like the best cheesecake ever?
Nah. Wait, the base of the prism is the height of the base.
So basically, it's would it be this one combined with this one? This one or no?
So this shape is a cone, but we are inside of a prism. So I do want you to.
These two.
So this one and the prism one from last chapter. Yep. Yes, because this is a prism. Mm-hmm. Yeah. So yes. Yeah, because this is the always the base. This is always the base. This is it's like the base is extended up. So your triangle is extended up to make a circle. So yeah. So the height of this.
Is it this one was food or is this? Is it this one?
This one. Yep, that one.
Okay.
Mm-hmm.
So you're just gonna find the volume of each.
Do you know the height of the base is 12 centimeters.
I should have said the base of the prism is 12 centimeters. So what is the base?
Base is over here.
The base is this entire thing.
Oh yeah.
Base of the prism, the entire thing. What is the height of that shape? How do we draw the height? So, yep. And that is cool. We did a problem very close to this like 2 days ago. Okay, I'm gonna move off the screen for like 1 second.
Wait, what's the formula? For cone?
We gotta find the area of. We gotta find how big the triangle is, and then once we find how big the triangle is, that's when we find the cone, and then we do the triangle subtracted the cone, and that gives us the area. So right now we just have to find how big the triangle is. Yeah.